All right, so yesterday we looked at relations and functions. Okay, sometimes when we drew things, they were just dots. Sometimes we actually connected the dots. Okay. Today we're going to look at functions, but we're going to focus specifically on linear functions. If you look at that word, linear, does anybody see like another word in it, Donovan? Line. So what we're going to be focusing on is things that are functions, meaning if you take a vertical line and you draw it, it never hits your graph more than once. And the type of graphs we're going to look at today are going to be straight lines. They're not going to curve. I think we had some that curved yesterday and stuff like that. No curves. Everything's going to be straight, right? So there's a standard way, and I think a lot of people already know it, that you write equations of things that are straight in math. It has an x and a y in it. And does anyone know the equation? It has an x, a y, there's a slope in there too, and a y-intercept. Chris?
Y equals mx plus b.
Yeah. It's y equals mx plus b. Now, that's not the only way to do it. That's probably the most common way, the way we're going to use most of the year. But that's y equals mx plus b. Now, the m and the b both stand for something. Can anyone tell me what the m tells me about this line? Yep. Not sure? Matt?
The slope.
The slope. So m is the slope. And what about b? Yep. It's the y-intercept. So if you had to describe these terms simpler, let's say somebody doesn't understand what the word slope and y-intercept mean, how would you describe slope to someone? What does slope tell you about the line? Yeah. Yeah, it tells you it's kind of at an angle. It tells you how steep it is, right? So if we said it has a big slope, that would mean it's very steep. Versus a number that doesn't have as big of a slope, maybe it would be more flat. And now, what about y-intercept? What does that mean? Yep.
Isn't that where the line crosses over the y-axis?
Yeah, it's where the line crosses the y-axis. So if I drew a line like this, and I asked you where the y-intercept is, it's right there. Okay. The graph also has an x-intercept. Right there. Okay, we don't use the x-intercept as much. We focus more on the y-intercept. Okay, it's where it crosses the y-axis. Now, if I had a line like this, let's say, here's my axes, and I'm going to make a line like this. Where's the y-intercept there? There isn't one. So not every single line has a y-intercept. Okay? Sometimes it doesn't. That's more of a special case. Right? Every other line besides the one I drew in blue will always cross the y-axis. The only time it doesn't is if it's perfectly up and down. Okay? But we'll talk more about special cases later on. Okay, so graph is a straight line. So, we already know what it means to be a function. Okay. Function means it passes that vertical line test. Wherever you put a vertical line, it never hits it more than once. Now we're going one extra step and saying not only is it a function, but it's a special kind of function, linear. And when you see the word linear, I told you guys to think of what? What word is in that? Line. So now you're thinking of, okay, things that pass that test we talked about yesterday, and they have to be straight. Okay? So that might be a function. Okay? Because if I take a vertical line, does a vertical line ever hit that more than once? No. But is that thing in blue straight? No, it's not linear. So that's a function, but it's not a linear function. It's not straight. And the only one that's we got to be careful with is it can't be vertical. Because if you think about, well, why can't it be vertical? Well, let's take that line in blue. Draw another line, do one in green, and let's drag it and see what happens. Does the one in green ever hit the one in blue more than once? Yeah. In fact, how many times do the green and the blue one hit now?
All of them.
Everywhere. All of them, right? Did the exact same thing. So that's why a vertical line is not a function. Okay? Maybe it's linear, yeah, it's straight, but it fails that test we talked about yesterday. So what makes something linear is the slope never changes. So if I had a line like that, if you were standing right here, and you had a friend standing right there, and you said to your friend, hey, how steep does this feel to you? Right? Well, how would they compare? If you're standing up here and your friend's standing down there, and you wanted to compare, hey, how steep does it feel for you where you're standing? How would it compare? Bob, no? Me? Yeah.
The lady?
Can you repeat the question?
So if you were standing here and a friend was standing there, how would the steepness compare?
It would be the same.
Yeah, it would be the same. Okay? Constant. It wouldn't change. You would both be standing on a hill that's exactly the same steepness. Now, let's pretend we had something that's not linear. Right? Let's pretend we had something like this. Actually, let's just use this one in blue. If you were standing here and a friend was standing there, would you both be experiencing like the same steepness now?
No.
No, it wouldn't be constant. You're standing on a spot that feels almost flat. Your friend is standing on a spot that feels like it's more slanted downhill. Right? It's not constant. Right? So when we talk about slope, we're going to talk about slopes that are constant. They're the same no matter where you stand. So a nonlinear function, that's like the one in blue. It does not have a constant slope, meaning if you stand in different spots, it feels like you're at a different steepness. Okay. Another example of that would be in this room. This is a constant slope, the floor. No matter where you stand, it feels the same. But if you're outside, like on a street that's flat, and then all of a sudden it starts to go downhill, that's an example of something that's nonlinear. It felt flat at one point, and then you stand somewhere else and it feels like it's going downhill or uphill. So nonlinear functions are not straight. They curve. Linear functions, straight. Does everyone have that?
Yes, sir.
All right. So this is asking us two things. One, does the graph represent a linear or nonlinear function? Two choices.
And guys, on your notes, you don't have the graph, so just draw it the best that you can.
Yes, sir.
So what do we think here? Linear or nonlinear? Chris?
Nonlinear.
Non-linear. It's still a function, right? Does everyone agree that if I put a vertical line, it never hits more than once, no matter where I put it? Yep, never hits more than once.
Yes, sir.
So it's a function, but it's not straight. So this is non-linear.
Question.
Yes.
On the test, could we just put like nonlinear, or do you want to say like nonlinear function?
Whatever the choices they give you, just use one of the choices.
Oh, okay.
So if they ask you linear or nonlinear function, then just write what they said. Yep. Because if I gave you something like this, What I just drew in black, is that linear or nonlinear?
Non-linear.
It's nonlinear because it curves. Is what I drew in black a function?
No.
No. So this is different. This is nonlinear and not a function. It's both. It's not straight and it fails the vertical line test. So nonlinear, not a function. This is nonlinear, but it is a function. Okay?
I get it.
Let's look at this one. So let's go through both questions. Linear or nonlinear? Linear, how come? Yep.
It's straight.
Straight. So this is linear, function, or not a function? Separate question. Yeah.
It is a function.
It is a function. So this is a linear
Equation.
function. Function because it passes the vertical line test. Linear because it is straight. Any questions on that one? Okay, and you guys got an example C. I think we got C on there too.
We had two C's actually, but we'll have to change one to D.
Oh.
Okay, linear or nonlinear? How about Dylan? What do you think?
Linear.
Linear. I agree. Linear. It's straight. No matter where you stand, it's going to feel like it's exactly the same steepness. Function or not a function? That?
Yes.
Yes. If you put a vertical line, no matter where you put it, it only hits once. So that's a linear function. All right, let's look at D. Okay, is that one perfectly straight?
No.
No, it's straight on each side, but it's got two sides. Linear has to be a line. That's not a line, that's a V shape. So that's nonlinear. Nonlinear. Okay, you might say, well, each side is straight. Yeah, but there's two sides. You can only have one. So if you got rid of this part, you did it like that, now you're good. Or if you got rid of the other side, but it can't be a V shape. So nonlinear. Function or not a function?
Function.
Function. Yeah, if you put a vertical line, no matter what, it only hits it one spot. So that's a nonlinear function. What if I put the V shape on its side? Linear or nonlinear? Still nonlinear because the shape is the same. Function or not a function? No, now it's not a function because if you put that vertical line in there, it hits it twice. So that's a non-linear and it's not a function. Okay. So is everyone, I think people are kind of getting the hang of that. Linear, non-linear, function, not a function. Okay. So you can have things that are, you can have all the combinations. We just pretty much went through all of them. All right. So next thing we're going to look at is, okay, people can seem to identify whether you have a function or not a function, linear or not linear from a picture. But can you do the same thing from a table?
Did we skip something?
Did we skip something?
Yeah,
It says those
it-
blank thing.
It
It's
is
a
a linear
nonlinear.
function if, and then there's a bunch of lines.
I'm not sure. So it says it is a linear function if, well, it's a linear function if it meets each word. So if it's linear, it means it has to be a straight line, and it's a function if it passes the vertical line test. So we'll put those two lines together. It is a linear function if it is a straight line and passes the vertical line test. So it is linear if it is a straight line and passes the vertical line test. Now, I think maybe this is coming up next on the notes, but there might be something we're going to add to that where when you're looking at a table, how do you tell if it's a linear function? I didn't look at the next page of notes, so that's probably what was supposed to go on that blank line. It is a linear function if.
We can add both. It's okay.
Yeah.
Low.
So, what I just said, you can keep that there, and that works if you have a picture. If it's a straight line and it passes the vertical line test. Both of those ideas are visual, right? Straight line, okay, it looks straight. Passes the vertical line test. I draw a line, never hits it more than once. I can't tell from this, is that a straight line? Well, it's not a picture. It's a bunch of numbers. So, does it pass the vertical line test? I don't know. I can't just put a line and drag it through it. I don't have a picture. So, let's look at this and see if we notice any patterns.
And guys, yesterday we gave you stuff like this, right? We gave you like the chart, and we asked if it was a function or not. So how do we figure out yesterday? We're not talking linear function, we're talking about what we know from yesterday. When we looked at one of these charts, how do we know if it was a function or not? Chris?
If one of the domains repeated or not.
Yeah, if the domains repeat, if one of the x's of the domains repeated, what does that mean?
Was it a function?
Not a function, right? Repeating is bad, right? You don't want to repeat because then it's not a function.
So we know
Today it's going to be, just like we talked about from the graph, right? Again, we know these are functions, right? You know all of them are going to be functions, but again, now we're trying to determine whether it's linear or not. So again, linear, they're not going to repeat. We're already telling you they're a function. There's going to be no repeats. You're just going to see if there's going to be a pattern or not. So again, understand the difference of how you identify.
So look at the x's. Does anybody notice anything in the x's? Matt?
They go up by 3.
Yeah, there's a pattern to it, right? So the x's go up by 3. Okay, they go up by the same amount each time. Okay, for this particular one, it's 3. Maybe it could be 2. Maybe it could be 5. But the point is they go up by the same amount each time. Now we're going to look at the y's. Yep.
They go down by 6.
They go down by the same amount each time. So the y's go down by 6. Right. Maybe in another problem they go up by 6. Maybe they go down by 5. The point is they do the same thing each time. Okay, so what we're going to do, we're going to just try to generalize that pattern so you can look at any table and determine is that linear or not. All right? This one is an example of linear because you have patterns for the x's and for the y's. So, the way you want to look for a linear function is you look at your table, and if the x's go up, or it could be down. So if the x's, I'm just going to put if the x's go up or down by consistently adding or subtracting the same number, y also changes using either addition or subtraction.
Yeah, we're not gonna be able to you don't want to have any multiplication or division for these. That's something we do later in the year. So the x's will be increasing or decreasing by the same number. The y's will be increasing or decreasing by the same number. But understand, just because the x's go up by 3 doesn't mean the y's have to go up by 3. It could happen, but usually not. Usually the x's are gonna increase or decrease by the same number, and the y's will increase or decrease by a different number.
And as Mr. Roy said, the key is that the pattern is addition or subtraction. So if you had something like 2, 4, 8, 16, 32, I'm doubling each time. I'm not adding the same thing each time. That is a pattern, but it's not the kind of pattern we're looking at today. So the pattern has to have addition or subtraction.
And guys, most of the time we're not going to ask you to explain, just that we identify the pattern. you know, I'm not gonna say is it a linear function or not, then I, explain the pattern to us, just know what the pattern is so you can answer linear or non-linear.
Everyone have that written down? Alright. So let's look at this. And let's just start just by looking at the x's. Does anybody see a pattern in the x's? Yeah, Garrett?
Goes up by 2.
Yeah, it goes up by 2. Plus 2. Plus 2, make sure you check all of them. Because if they threw in like an 8 on the last one, like that, now they messed up the pattern. Doesn't work. So check them all. Plus 2, plus 2, plus 2. So do we have enough information now to answer the question if it's linear or non-linear? Matt, you're shaking your head. How come?
Because it has to be consistent in the y.
Yeah, I got to have a pattern in the y's that has adding or subtracting. Right? I've got a 2. Is that enough information to tell you if there's a consistent pattern?
No.
No. My next one is now 9.
Wow, interesting.
Is that enough information to tell you?
No.
No. You need a third one. What did you do to get from 2 to 9?
That's what I said.
Add 7. So if this is going to be linear, what would the next number have to be? Plus 7, which would have to be a 16. If it's not a 16, then this one would be non-linear. Let's check. It's a 20.
Boy.
Oof.
I was gonna be told. Why?
So that time,
Plus 8, right?
Hashtag non-linear.
No.
that time you added 11, so that's no good. And then after that, you added 5. This one's the pattern. There is no pattern. It's bouncing all over. So this is non-linear because there's no pattern. And somebody answered earlier, why is it a function though?
The x never repeats.
Exactly. You can't say that it passes the vertical line test. We don't have a picture. If we had a picture, it would. But the x never repeats. That makes it a function. The fact that there's no pattern in the y's makes it non-linear. Linear or non-linear function. So right, non-linear function. Okay. Any question on that one? All right, let's check another one. X's are 0, 1, 2, 3. Is there a pattern there? Matt? Yeah, we're plussing 1 each time. Plus 1, plus 1, plus 1. My next y is 3. Do I know yet if it's a linear or non-linear function? No. 5. Do I know now? No. What did I do to get from 3 to 5?
2.
So if this is going to be a linear function, what does the next number have to be?
7.
It has to be 7.
Oh my god. Yo, watch the next one now.
Do I have enough information now to tell if it's linear or non-linear?
Not really.
Not yet. I still got to check the last one, which we're going to hope is 9. And this time it is. So this is a function, because there's no repeats in the x. What kind of function?
Linear.
Linear, perfect. So it's a linear function. So there's all kinds of things. You could have linear function, you could have linear non-function, you could have both. All right, let's look. I think we got one more. No, we just have a lot of space.
Yeah, we have a D on here.
Oh, we have a D.
Wait now,
Okay, pattern in the x's. Do we have one?
Right here, mister.
Yeah.
It's +1.
Plus 1. Plus 1. plus 1, plus 1. My first y is 16.
That's a big number.
Do I have enough information to answer if it's a function or not? A function.
Is that a function, guys? Yes or no?
Yes.
Why?
Because the accessory.
X's don't repeat. Good.
Yes.
No repeats in the x's. Now, how about, what are we looking for? Do we know the pattern yet?
No.
No, we gotta see another one.
To reveal it. Okay. Fine.
What did we do that time?
Subtracted 8.
Subtracted 8.
Divide by 2.
Or divide by 2, right? But remember, if the pattern is we keep dividing by a number, is that linear? No, that's something else, but that's not linear. So we minus 8. What should the next one be?
0.
Should be 0. It's not.
Disappointment.
So the pattern here is we're dividing by 2. But that's not linear. You've got to add or subtract the same thing. So it's a non-linear function. So that means it would pass the vertical line test, but it would look like a curve. This one would look like this. If you were to draw it, that's what it would look like. Okay, any question on that? Now, I want to show you guys one more thing. What if I had this? 1, 2, 3, 4. Okay? And then I had 5, 10, 15, 20. Is that a function? Yep.
Yes.
Is it linear?
Yeah.
Yes. Now,
Yeah, boy.
what if I did this? Basically, I did something like that.
Well, hold on. Let me see what you're doing.
Yeah. That's still function.
It still is a linear function.
Yeah.
I left out something. So, I don't think you're going to see one like that. But on MCAS or something, that would be a little tricky because you might say, oh, it's plus 1 and plus 2. But the way I look at it is I say, all right, if I look at that and I say, you know what? It looks like there's kind of a pattern here. 1, 2, they skip something and then a 4. 5, 10, they skip something and then a 20. If I can fill something in like that, and then it makes the pattern complete, that's still a linear function. All right? So for us, you're not going to have to fill anything in like that. But just look for that, like when you take MCAS or something, if they skip something, but it looks like, oh, if they just put in those 2 numbers, there would be a pattern, then it could be a function. So that's a little tricky, but it could
What if they don't
happen.
think that way?
What's that?
What if they don't think that way? Like, what if they don't think that you just have to add those numbers and then
They're smart.
it would be a function?
I'm not.
But it's not like,
Yeah, it depends on the problem, but I mean, I'm just saying they could throw something at you like that, which unfortunately that I think would trip up most people if they did. Yeah. Okay, but we're not going to try to trip you up with something like that. But.
Alright guys, so we've talked about linear functions, right? What are some things we've looked at to identify linear functions? What have we looked at so far, right? Like Yusuf said, a picture, right? So how do I determine, based on a picture, someone raising their hand, how do I determine whether it's a function or a linear function?
You do that line testing, like you.
That's determine if it's a function. I want to know, how do I determine based on a graph if it's a linear function?
Well, that would tell you the second part of what he said. So it does tell you it's a function.
Yeah. How do I know if it's linear or not?
Oh.
Bethany?
It has to be a line.
I mean, it has to be a line.
It has to be a
Straight line, right? Again, if you're looking at a graph, right, or like Yusuf said, a picture, to determine whether it's linear or not, it has to be a straight line.
Except for.
Except for what? What type of line?
Like a U shape.
Well, U-shape's not a line, but there's one line that's not a linear function.
I mean, it's like
Gigi?
low-key.
Vertical, right? Up and down. All right? So again, if you're looking at a picture, for it to be linear, it has to be a straight line. What about looking at a picture for it to be a function? Or looking at a graph for it to be a function? Not a linear function, just a function. How do I know looking at a graph if it's a function or not? Linear, we just said, linear is going to be a straight line. What if it's just going to be a function only? We're asking you to identify if it's a function or not a function, looking at a graph. What can I use? PG?
Vertical line.
Vertical line test, right? What does that mean?
Like,
Draw a line, and then what?
and like drag it through, so make sure it doesn't hit more than one.
Yeah, if it's more than once, it's not a function. So you guys, you got to understand the difference. Linear, straight line. If we're asking based on a graph, for it to be a function only, do the vertical line test. Alright? So linear, when you can't see linear, think line. They give you a graph, ask if it's linear or not, straight line. If we're asking for a function looking at a graph, vertical line test. Alright? What's another way we looked at? Another thing we looked at to see if it's linear or non-linear. We just did. What else can we look at? We can look at graphs to determine. What else can we look at? Bethany? Huh? A table, right? Or a chart. Alright? Based off a chart, how do I know if it's a function or not a function? Based off a chart. Not asking for linear or non-linear, I'm just asking if it's a function or not.
The x repeats.
Again, if the x repeats, what does that mean, Chris?
It's not a function.
Not a function.
Good job.
If it repeats, not a function. If it doesn't, you have a function. Now, take it one step further. Looking at a chart, how do I know if it's a function or not? What do you think, David? How do I know if it's a function or not, looking at a chart?
Well, that's what we just demonstrated, right?
Yeah.
Repeats.
I'm sorry, I don't know if it's a linear function.
If there's a pattern.
Yeah, look for the pattern. Again, looking at a chart, function, no repeats. Linear, look for the pattern. So you gotta understand the difference. Again, I've seen people on this test get screwed up. Linear, graph, straight line. Function, vertical line test. Chart, alright, if I'm looking at a chart, no repeats, function. Pattern, linear function. You gotta be able to understand the difference. Alright, so like we told you guys at the beginning of this lesson, right? Y equals mx plus b. That's a linear function, right? You got your slope, you got your y-intercept. Why is that a linear function? What's going to happen when you graph that? You start your y-intercept, you go up 2 over 1, up 2 over 1. What's it going to look like once you graph it? Straight line, right? That's why it's a linear function, because when you plug in numbers for it, it'll give you a straight line.
Yes, sir.
Now, we're going to ask you, so we've looked at graphs to see if they're linear or not. We've looked at charts to see if they're linear or not. Now we're going to look at some equations and see if they're linear or not. This is based on what's included in the equation. So, if you have square roots with variables, so say you had something like y equals the square root of a. Again, when we get to the end of going through this, guys, it'll make sense. And guys, Mr. Hager just graphed it, right? He just did that on his graphing calculator. That's y to the square root of a. Is that, Jake, is that linear?
No.
Why?
Not a straight line.
Not a straight line. We know it's a function, right? It's not asking us that. It's asking if it's linear or not. Alright? It's not a straight line, so it's not linear. If you have variables in the bottom of the fraction, so you had like y equals 2 over x. So Mr. Hager's going to graph that right now. Look it. Again, like Jake told us before, it's not a straight line. For linear, when you're looking at a graph, it has to be a straight line. If we're asking for a function or not, then vertical line test. But again, linear, straight line. If you're looking at a graph and it asks if it's linear or not, it's just going to be a straight line. That's all you have to do. Alright? So you can't have any variables in the bottom of a fraction. It won't work. It won't make it a straight line. If you have variables as exponents, like this one, y equals 4 to the x. So Mr. Hager's going to do that right now in his calculator. We're showing you all these situations and why they don't work. All right? This is called, we'll get this like late in the year, this is called an exponential. It starts off really slow, then goes up really rapidly. All right? Again, variables as exponents, that doesn't work. All right? Variables with exponents other than 1. So say if you had y equals x to the second power. We know every number that we write, every number or letter that we write is to the first power. We just don't write to the first power all the time. All right? So y equals x to the second. Mr. Hager just did it. This is called a quadratic. You'll get to this next year. This is a quadratic. Again, it's not a straight line. It's not linear. Again, I'm not asking you to know whether it's exponential or whether it's a quadratic. That doesn't matter. Just know if it's a straight line, linear. Not a straight line, not linear. And again, you've got to be able to know when we look at different equations based on what's included in there, are they going to be linear or not? Right now is our last one, right? All right. Be careful for something like this too. If you had something like that, I'll simplify it. Do I have any of these scenarios going on in that equation?
No.
No. So would that be linear or non-linear?
Non-linear.
This would be linear because there's none of this funky. I call this stuff here, all of these 4 situations, I call it funky stuff. So if there's no funky stuff going on in the equation, you have a linear equation. If there's funky stuff going on, square roots, variables with exponents, variable exponents greater than 1, any weird stuff going on or funky stuff, that tells you that's not going to be a function. All we're going to do is give you the equation, you look at it, tell us if it's linear or non-linear. Yusuf?
So all those are examples of
All these are things that, if these things were included in an equation, they would not be a linear function. It's like it says right here. These type of equations are not functions.
So basically, Yusuf, you always want something that looks just like that. Or like Mr. Roy showed you, something you can do the distributive property to, and then it looks just like that. So it has to always look like what's
Or
in
even if
that
you had
box.
something like this.
Okay.
If I had that, y equals 2x. Matt, linear or non-linear? Linear. There's no funky stuff going on, right? It's basic. It's how I want it. Could have something like this. What do you think, Savannah? Linear or non-linear? Linear, right? These are like special cases. But there's no funky stuff going on. There's no square roots. There's no exponents. There's nothing like that. All right? So that's how you do these. All you're doing is looking at the equation and say whether it's linear or non-linear. Just like when we looked at a graph. If it was straight, it was linear. If it was not straight, it was non-linear. Just like when we looked at the chart. If the chart followed a pattern, it was linear. If it didn't, it was non-linear. Here, if there's none of these situations going on, it's linear. If you have one of those situations, it's non-linear. Right? So those are like 3 of the ways we'll look at to say whether something's linear or non-linear. Graph, chart, equation. All right? So on your notes, I'm going to give you. So this one, A. Brady, is this going to be linear or non-linear?
Non-linear.
Why do you say non-linear?
Because it's not even.
Doesn't matter. Again, are there any square roots there? Are there any exponents there? There's exponents in this? No, there's nothing weird going on here, right? Looks like a regular old variable with a number, right?
So it is.
Well, we gotta be careful. Because we always want to make sure for it to be a function, it has to look like this. For it to be a function, there has to be a y in it and an x in it. If that x is gone, that's a problem. Okay, so your goal is to have it look like that. When we look back, let's copy that down. In this case, do I have a number in front of an x in that problem? No. It's going to be linear. I agree. It is going to be linear. It's going to be, in fact, I'll just show you what it looks like. It's going to be a horizontal line at 3.8. It's a special case. But in order for it to be a function, usually we have a number with x. So I would say for that one, let's hold off on that one for a minute. Let's just look at all the other ones. Okay, I'm going to double check and see how our book defines that one.
Okay.
But everything else I think is clear. So hold off on A for a second, and I'll get back to you.
Hey guys, we're just gonna skip back and forth. So we'll go A, E, then we'll go back, and then we'll go B, the next one. All right. So E, linear or non-linear? Ellie?
Linear?
Linear. Again, be careful because you may think, well, wait a minute, Mr. Roy. It's got the parentheses.
Isn't that like a special case?
Do what's in the parentheses first and see how it comes out. So what do these parentheses mean? What math operation? So when I multiply Donovan, what do I get?
6x.
Yep.
Negative 6.
Minus 6. Again, no funky stuff. I got a number with x. There's no square roots. There's no exponents. There's none of that stuff going on. So this would be a linear function. Again, there's no funky stuff. There's nothing in there that looks really weird. We got a y, we got an x, we got a number. We're good. All right. Let's look at B. How about Alex? Would B be linear or non-linear?
Non-linear.
Yeah. We're gonna say for this one. Want to say no. For this, just put no, right? That's okay, right?
Yeah, if it asks which of the following represent, yeah, you could put no.
Yeah, this one would not be. So it doesn't matter what, long as you can identify the ones that are linear functions, you're fine. This one's a no. Alex, why did you say no for this one? All right, but what did you see there that made you say no? What funky thing was going on there that made you say no? Yeah, the square root, right? We don't want any square roots. We talked about that when we looked at all our different scenarios that would make it not a linear function. All
Let's
right.
jump back to A for 1 second,
Sure
just to
thing.
clarify that. So I showed you guys the picture of A, okay, and I wanted to double check something in our book. Is that what I drew in A? Is that straight?
Yeah.
So it's linear. If I put a vertical line, no matter where I put it, would it ever hit more than once? No. So that, based on the picture, that is a linear function. So A is a linear function. In fact, it's a special type of linear function we call a constant function. Because if you look at it, it's constant. It's perfectly flat. Never changes. All right? You don't have to know that it's a
Yeah, but
constant.
just know that it would be linear because you don't have any, again, no exponents, no square roots, none of that stuff. All right. F. How about Matt? Is F going to be linear? No. It would be no, right? What made you say that, Matt?
The x has a...
Yeah, x to the second power, right? We don't want any value. We don't want any exponents greater than 1. So this would be a no. F is a no. C. How about the jelly? Is C going to be a function? Is C going to be a linear function? Huh? If you're not sure, look at those notes we wrote down. The different scenarios you could have that would make it not a linear. So is it linear or not? Don't ask anybody else. I'm asking you, not. Why?
I don't know.
Somebody help her out. Allie?
Because the variable has an exponent.
Yeah, we don't want any exponents that are variables, right? Again, that's the funky thing that's going on here that makes it not a linear function. Sorry, Mr. Hager. And again, there's an example of it right there. Mr. Hager just graphed it on his graphing calculator. That's what he got. So C is going to be a
Non-linear.
no. How about G? Garrett, is G gonna be a linear function?
Yeah,
Why?
because it's not funky.
Yeah, there's no funky stuff right going on. I got a Y, I got an X, I got a number, right? I got Y equals something, I'm good. That's what it looks like as a graph. Again, a nice straight line. Again, we know it's linear, so we know it's gonna pass the vertical line test. So linear. How about D? Miguel, is D gonna be a linear function? Why? Is that? It's gonna, we're dividing by an X, right? In those notes that we took, we said we can't divide by a variable, right? So that's, again, there's what it looks like. Let's say you did it on his calculator. D is a no. How about H? Allie?
Would it also be a non-linear because it's a fraction?
It's okay to have a fraction. But again, it would be not linear if I had X on the bottom, right?
Okay, so it is linear.
It would be linear,
Okay.
yes. Because again, when I look at, say I just graphed it. If I scroll up, I have the number with X, right? Does anybody know what that M stands for in that formula? Slope, right? The number with X is always the slope. That's my slope, all right? So I would go up 3 over 5. Up 3 over 5. I would start at 0 though, because I have no y-intercept. So I'd start at 0, up 3 over 5, up 3 over 5. It would give me, again, it would be constant, it would be a straight line, all right? So that's what that would look like. If I did y equals 3 over 5x, that's what it would look like. Mr. Hager showed you up 3 over 5. If he goes up 3 over 5 again, he'll end up on that same line. So again, that one's a little tricky because, but again, it doesn't meet any of the criteria to make it not a linear. There's no variables in the bottom that you're dividing by. There's no square roots. There's no variables as exponents. There's no exponents greater than 2. So again, that's another reason why I would make it linear. Again, that's what it would look like right there. So H would be linear function. So again, like I said, we looked at 3 ways today to identify whether it's linear or not. Graph, and it's going to be a straight line. Chart, and it's going to follow a pattern. Chart is going to follow a pattern, and then no funky stuff. All right. Tonight's homework, it's only like 5 questions. It's pretty short. Again, guys, you can still have I have some review problems for you guys to do too. You got like 15 minutes before we leave anyways. The reference sheet's gonna be posted by tomorrow night. All right, so make sure you get on there and try to get started tomorrow night so you don't have so much to do on Thursday night. Remember, Mr. Hager said at the beginning of the week, we have no review day this week. Again, because we're not in academics again until after Thanksgiving break. So there's no room for review this week. Usually, the lesson we do the week of Thanksgiving, we're doing that Thursday because we don't have any academics the week of Thanksgiving. All right, so there's no review day this week. First test of second quarter is this Friday. Again, this is just second day in academics of second quarter. You guys will get your report cards on Friday during 9th period. All right. We may share their grades with them maybe Thursday or something, right? They can go online and get them anyways, right?
Yeah.
Their first quarter grades. All right. Cool. Guys, if you have some scrap paper, you can do these review on the scrap.